Hey guys, welcome again to the discussion on limits. This time we will be discussing about the topic algebra of limits. Let's say we have functions f of x and g of x and we are evaluating limit at x approaches to a. Let's say this is the point at which we have to evaluate the limit. And both of these limits, limit x approaches to a f of x and limit x approaches to a g of x exists. Okay, so then the limits can be evaluated according to the normal algebra. So we will be focusing on those things. The first is the addition. So I'll be explaining this with an example. So let's say we have fx is equal to x square plus x and gx is equal to, let's say fx is equal to x square and gx is equal to x plus 1, let's say, and we have to evaluate limit x approaches, let's say 1, f of x plus g of x, and this function is the result of addition of two functions. So how we can evaluate limit here? So we assume that this limit exists at x equal to 1 and this limit also exists at x equal to 1. So we can just break up these two limits according to the addition rule. So this will be limit x approaches to 1 f of x plus limit x approaches to 1 g of x. So this is like we are splitting in the form of addition. So this will be 1 squared, which is 1, plus x is approaching 1, so x square will also approach to 1, and here in gx we will put the limit and gx will approach to 2, so the answer is 3. So this is the basic example of the addition of limits. Similarly, we can focus on the subtraction rule. So let's say fx is x square and g of x is x minus 3. So we will have to evaluate limit x approaches to 1 f of x minus g of x. So this is the bigger function f of x minus g of x. Now since according to the previous thing, like in addition, here also we can split these limits according to subtraction. Since both of the limits are existing at x approaches to 1, at fx also and at gx also, so we can split it as x approaches to limit x approaches to 1 f of x minus limit x approaches to 1 g of x. So this will be 1 squared, that is 1, minus 1 minus 3, that is minus 2. So the answer is coming as 3. So this is an example of subtraction rule where two functions are in subtraction and we are evaluating the limit. So we can just break them in the form of subtraction and evaluate. Similarly, we can have multiplication. So this is the multiplication, and let's say f of x is equal to x square plus 1 and g of x is equal to x plus 100. It's some random function I'm taking. So we will have to evaluate limit x approaches to 2 f of x multiplied by g of x. So this is the function on which we have to evaluate the limit fx into gx. So now we first check that this limit x approaches to 2 f of x is existing and limit x approaches to 2 gx is also existing, right? So we can just simply now split it according to the multiplication rule. So we can say this thing as limit x approaches to 2 f of x into limit x approaches to 2 g of x. So this will be 2 square plus 1 times 2 plus 100. So that would be 5 times 102. So this will be 510. So similarly, we can have division also. So let's say f of x is equal to x square and g of x is x minus 2. So in this thing, we have to take into account one more fact, that these two limits need to exist, but also like in division, one more thing, like if the limit is evaluated, let's say x approaches to 2 f of x, so this fx by gx, so this g of x should also be should not be equal to 0 at the point, because then the limit will not be defined. Okay, so and in fx and sgx and yeah, this as well, so the limit is existing, so we can now split it according to the division rule here. So this will be limit x approaches to 2 fx over limit x approaches to 2 g of x. Now we'll check one more thing, that this gx is existing and this limit x approaches to 2 gx should not be equal to 0. So this gx should not approach to 0 at this point. But when we put the limit, that is limit x approaches to 2 g of x, the answer of this function is coming as 0. So that means this limit does not exist. This limit x approaches to 2 g of x is not existing. Okay. But this limit is not existing, so we can say it is undefined. Now since denominator can't be 0, so this is the basic uh, concept of algebra of limits which I have introduced in this video. So guys, this was it for this video. Do join me in the next video. We will cover the L'Hopital rule. Thank you guys.